One of the most interesting things that we learn in math is about prime numbers. So, welcome to this video where I would like to show you in some rudimentary level how you can intuitively understand uh, prime numbers that are less than 100. Okay, so this is the prerequisite for this video would be for you to understand basic divisibility or understand the concept of multiples of different numbers and the idea of what a prime number is. So, what is a prime number? So, prime number is basically any number that has only two factors, one and itself. But it's kind of hard to figure it out because pretty much every number that you come across is definitely going to have one and itself as its factors. The problem is that it has many more factors. The prime numbers have only those factors. So, just by looking at a positive definition of the prime number, it's not very intuitive to figure out a particular prime. Instead, you should do the other way around, which is to actually say, if I eliminate all the other factors available and ensure that none of those are factors for a particular number, and therefore logically I'm left with only the number 1 and the number itself as its factors, then I can arrive at the conclusion that the number is a prime number. But nevertheless, I think the key idea here at the end of this exercise is to know the prime numbers and become very familiar with it, because that comes in very handy in most arithmetic and mathematical problems. So what do we do? So we have a hundreds chart. You can go to this website called Toy Theater and it allows you to interactively play around. So if you click on hide, I think it removes all the numbers. So what we'll do is try and do it in a very simple fashion. Okay. So now we know that 2 is prime. So let's mark everything that's prime in green. So we know 2 is prime because the only factors for 2 is 1 and 2. What about 1? 1 is, I would say, neither prime nor composite. So we'll mark that in black. That's the exception to the whole thing. So now since 2 is a prime, what about all the numbers which are multiples of 2? They can never be prime, which means 4 can't be prime, 6 can't be prime, 8 can't be prime, and 10 can't be prime. Not just that, everything in this entire column, as in all the numbers that end in 4, end in 6, are not going to be prime. Right? So you can basically click on each one of them and say that, hey, none of these are going to be prime. What about 3? 3 is prime. We'll come back to 3 later. But 5, 2 is not prime, which means every number that ends in 5 is also not going to be prime. And every number that ends in 2 is also not going to be prime, something we missed when we looked at multiples of 2. So now if I hide this, everything that's orange is not a prime. So all the prime numbers need to be in these white squares, in one of these white squares. But let's see how it goes from here. Let's think about 3. Every multiple of 3 is not going to be prime. So we know 6, we know 9. And 12 and 15 already taken care, 18 is taken care, 21. So you can think of only the odd multiples of 3. So 27, 33, 39, 45 is taken care, 51, 57. You can see a pattern for 3. We'll do that in a different video. 63, 69. After 69, 75 is taken care, 81, 87. What after that? 87 plus 6 is 93 and 99. So these are all related to 3. So let's hide it again. So all the prime numbers that are ever there, less than 100, is going to be in one of these white spots. Let's think about 7. 7 is the next one that we think about. 7 is a prime number, which means all the odd multiples of 7 is something you want to look at. 21 is taken care of. 35 is taken care of, but not 49. Right? So 49 is something that is multiple of 7, so therefore you have to take care of it. What about 7, 7, 7, 9, 63 is taken care of. 7, 11, 77, that's something you want to look at because you've not come across this so far. And 7, 13 is 91. So I think this pretty much leaves everything else as prime numbers. So let's mark all of those in prime: 11, 13, 17, 19, 23 and 29, 31 and 37, 41, 43, 47, 53 and 59, 61 and 67, 71, 73, 79, 83 and 89, 97. So let's hide this, and you can see everything that's in green is a prime number. Everything that's orange is composite, and the one in black is neither prime nor composite. So this is basically the grid of prime numbers in 100. So now let's spend a little bit more time thinking about it from a column perspective. So 11, 31, 41, 61, 71 are all primes. So there are 5 primes which ends in 1. The ones that are not primes are 21 because it's 3 times 7, 51 because it is 17 times 3, 81, again multiple of 3, 91 because it's multiple of 7. In the 3s, it is 3, 13, 23, then 43, 53, 73, and 83. 5, there's only 1, which is 5. For 7, it's 7, 17, 37, 47, 67, and 97. 19, 29, 59, 79, and 89. So the smallest prime number is 2. The largest prime number less than 100 is 97. So get yourself familiarized with all these prime numbers, and it'll come in very, very handy in a lot of number theory problems and mathematical and arithmetic problems. This is also of historic significance. This is called the Sieve of Eratosthenes. So there was a Greek mathematician, philosopher called Eratosthenes who basically came up with the exact same exercise to say that everything that passes through is not going to be prime. So that's the orange numbers. And everything that stays back, when you put it through this test of divisibility, everything that stays back is going to be a prime number. I hope you found this useful. I would suggest you try and do this for 1 to 100 and try and replicate the same thing for 101 to 200 to see how many prime numbers you're able to identify. I hope you found this useful, and I wish you great holidays and a wonderful new year ahead. I look forward to meeting you in the year 2024. So if you haven't done it yet, please subscribe to the channel, click on the bell icon and like this video so that we can keep the gods of YouTube very, very happy. All right, thank you so much.